All right, let's jump into another deep dive. Today, we're going to be tackling something pretty cutting edge, code prompts.
Oh, very cool.
Yeah, you're interested in knowing, whether using instructions that are actually written like code is a better way to talk to, large language models than just using plain text prompts.
Right.
You've even sent over some research papers and a real-world chatbot example for us to unpack.
Awesome.
So do code prompts really make LLMs smarter?
Yeah.
Especially for those like trickier reasoning tasks. Do different code styles actually impact how well they perform? And are code-focused models just inherently better at this than more general language models?
Right.
Let's find out.
Yeah.
One example that you sent over that really caught my eye is a chatbot that teaches Arduino using code-style prompts. I mean, how cool is that?
That's really cool. It's certainly an intriguing application, and we'll definitely get to that later.
Okay.
But first, let's dive into some of the research that you've provided.
Okay.
The first study, which is titled Exploring the Curious Case of Code Prompts, tackles this head-on.
Okay.
They compared code prompts against your regular text prompts across 12 different natural language processing tasks, and they used 3 different GPT models.
Interesting. And what did they find? Were code prompts like the clear winner, like everyone's been hyping them up to be?
Well, the results were a bit more nuanced than that.
Okay.
So code prompts didn't consistently outperform text prompts across all tasks. In fact, they sometimes performed worse.
Oh, wow.
However, they did significantly boost performance when it came to certain reasoning tasks.
Okay, so there's something to be said about using a structured approach for certain types of problems.
Right.
What kind of boost are we talking about here?
For example, on a task involving figuring out the order of steps in a WikiHow article, code prompts increased accuracy by over 10%.
Wow.
It seems code's structured nature might just give LLMs an edge when it comes to that logical thinking.
Okay, so not a magic bullet, but definitely promising for specific applications.
Right.
Is there anything else from this study that jumped out at you?
Yeah, one interesting observation
was
that fine-tuning the models on plain text instructions actually improved the performance of code prompts.
Oh, interesting.
So even though we're dealing with code here, a strong foundation in understanding natural language seems crucial.
Yeah, it sounds like these models benefit from like a multifaceted approach to language, which, makes sense given how intertwined code and language are in the real world.
Right.
Were there any limitations to this study we should be aware of?
Yeah, the study does have some limitations.
Okay.
Particularly around the specific GPT models they used. OpenAI has since deprecated code DaVinci 002.
Okay.
Making it challenging for others to replicate the findings. Also, there's the potential for data overlap between the model's training sets and the tasks that were used in the study, which could skew the results.
Right. So always important to keep those limitations in mind when interpreting research findings.
Right.
Shall we move on to the second study you sent?
Yeah, let's do it.
This one is called Prompting Language Models with Pseudo-Code Instructions. What makes this study unique?
What's fascinating about this study is their approach.
Okay.
Instead of using existing programming languages, they created a set of 132 pseudocode prompts across a variety of tasks.
Interesting.
Think of it as like simplified human-readable code.
Okay.
They tested these prompts on 2 large language model families, Bloom and CodeGen, neither of which were specifically trained on the instruction set used in the study.
Okay, so a fresh set of eyes on these pseudocode prompts.
Right.
What were the results? Did the LLMs understand these simplified code-like instructions?
The results were pretty impressive.
Okay.
These pseudocode instructions led to some significant improvements in performance. They saw increases in accuracy by 7 to 16 points on classification tasks, suggesting that a structured approach, even if it's not formal code, can be incredibly effective.
That's quite a jump.
Yeah.
It seems structure in any form could be the key here.
Right.
Did they explore any specific elements within these pseudocode prompts?
They did. They conducted what are called ablation studies,
Okay.
where they removed certain elements from the pseudocode, like comments and docstrings, to see how it impacted performance.
What did they find? Did those elements make a difference?
Interestingly, removing those elements consistently lowered performance. This suggests that it wasn't just the structural cues of the pseudocode that were driving those improvements, but also the information conveyed in the comments and doc strings.
That's fascinating. So it seems that the content within the structure matters just as much as the structure itself.
All right.
Yeah.
And here's another intriguing finding. They observed that even regular text prompts benefited from adding those pseudocode elements like those comments and doc strings.
Oh, wow.
So it seems like there's something about that structured way of conveying information that helps these LLMs regardless of the base language being used.
So we've got these two studies pointing to the potential of structured prompts, whether using actual code or a simplified pseudocode approach.
Right.
But how does this translate into real-world applications? I'm eager to learn more about that Arduino chatbot example you mentioned earlier.
Let's shift gears then
Okay.
and delve into the real-world implementation of code prompts with Generative, a chatbot designed to teach students about Arduino and the world of the Internet of Things.
That's quite a name.
It is.
How does this chatbot actually utilize code prompts in a learning environment?
So Generative is built with a glossary of over 100 Arduino and Internet of Things terms,
Okay.
covering both hardware and software aspects. It randomly selects a keyword from this glossary and starts asking the student questions about it.
So it's using code prompts to engage students in like an interactive learning experience.
Right.
What kind of questions does it ask?
It can pose multiple choice questions or open-ended questions,
Okay.
depending on what's called the params field associated with each term in the glossary. This params field basically controls how Generative interacts with the student for that specific keyword.
Clever. It adapts the interaction based on the term and how complex it is.
Right.
What happens after a student answers a question? Does Generative just say, like, right or wrong, or is there more to it?
This is where Generative goes beyond your typical quiz format.
Okay.
Instead of just giving a right or wrong answer,
Yeah.
it offers explanations, code snippets related to the keyword,
Okay.
and even links to relevant resources online.
So it's not just about testing knowledge, it's about guiding learning and providing valuable context.
Yeah.
Is there anything else that makes Generative stand out from other educational chatbots?
It also adapts to each student's pace and uses humor and emojis to make the learning experience a bit more engaging.
Oh, wow.
Imagine a chatbot that cracks jokes and uses emojis while teaching you about Arduino.
That definitely makes it more approachable than a dry textbook. Is there anything unique about its design on like a technical level?
Yeah, Arduino is built using a state machine approach,
Okay.
meaning its behavior is determined by a series of states, each governing a specific part of the interaction.
Okay.
Think of it like a carefully crafted flowchart guiding the learning process step by step.
So we've got this real-world example of a chatbot that uses code prompts, a glossary of technical terms, and a carefully designed state machine to guide students through learning Arduino. It's amazing to see these research findings come to life.
It's a compelling demonstration of how code prompts can be applied in a practical setting.
Yeah.
However, it's important to remember this is just one specific application. More research and diverse implementations are needed to fully understand the potential and limitations of code prompts in education and beyond.
That's a great point. Generative offers valuable insights, but we shouldn't overgeneralize its success.
Right.
Now, let's take a step back and connect these dots between the research and the real-world example.
Indeed. We've explored the theoretical groundwork and witnessed a real-world application.
Yeah.
What can we glean from these insights?
Let's unpack that.
Welcome back.
My brain is definitely buzzing with all sorts of ideas.
Well, good. I hope so.
Before the break, we were discussing how Generative, brings this concept of code prompts to life. It's clear that these prompts hold a lot of promise.
Right.
But you mentioned that context is key when it comes to actually using these code prompts effectively.
Yeah.
What exactly does that mean?
So when we talk about context, we're looking at a few things.
Okay.
First, the task itself. Some tasks they naturally lend themselves to a more structured code-like approach. Things that involve logical reasoning, step-by-step instructions, or even like generating creative text formats.
Oh, okay.
Like poems. Or even code.
So anything where a clear, precise set of instructions would be beneficial.
Exactly.
Like writing a recipe, explaining a scientific concept.
Yeah, that sort of thing.
That sort of thing.
In those scenarios, code prompts can really shine.
Okay.
However, for tasks requiring more nuanced language, emotional intelligence or subjective interpretation,
Okay.
traditional text prompts might still be a better fit.
Right, so it's not about replacing text prompts entirely,
Right.
but it's about recognizing that code prompts are another tool in the toolkit,
Exactly.
best suited for certain types of challenges.
That's a great way to put it.
Yeah.
Now, the second aspect of context is the model itself,
Okay.
as we saw in those research studies.
Right.
Models trained specifically on code, like CodeGen, they tend to perform better with code prompts,
Yeah,
almost as if they speak the same language.
that makes sense.
Yeah.
But what about models that haven't been trained on code? Can they still benefit from code prompts?
That's a question that researchers are still exploring.
Okay.
There's some evidence to suggest that even general-purpose language models can see improvements with code prompts on certain tasks,
Okay.
but the results aren't as consistent.
It seems like there's still a lot to uncover in this area.
Yeah,
It's a bit like the Wild West of prompting right now,
it is.
but that's part of what makes it so exciting.
Absolutely. It's a rapidly evolving field, ripe with potential for new discoveries.
Yeah.
And this leads us to the third element of context,
Okay.
the style of the code prompt itself.
Right.
Recall that first study we discussed.
Yeah, they looked at like 4 different styles. From like a basic prompt with no variables or comments to a more complex prompt that was using like a class structure
Right.
with identifiers and comments. And if I remember correctly, the style that consistently performed the best was the one with variable identifiers and comments.
Yes.
Yeah.
It appears that adding those comments
Okay.
and using meaningful variable names, it helps the LLMs better understand the task, even if the underlying code structure is the same.
Right.
Almost as if we're not just giving them instructions, but communicating intent and providing context through the code itself.
It's almost like we're teaching these LLMs to think like programmers,
In a way, yes.
breaking down a task into its logical components and providing, clear, well-documented instructions.
By using those code prompts effectively,
Yeah.
we're helping them to grasp the underlying logic and structure of a task,
Yeah.
leading to better performance and more accurate outputs.
It's fascinating.
Who knows?
Yeah.
This might even lead to new and unexpected capabilities in these LLMs down the line.
So we've talked about the importance of context when using code prompts.
Right.
But stepping back for a moment, what does all this mean for the future of prompting in general? Are code prompts just a fleeting trend, or are we witnessing a fundamental shift in how we interact with these models?
That's the million-dollar question, isn't it?
It is.
As with any new technology, it's difficult to predict the future with absolute certainty. But I do believe that code prompts represent a significant shift in our thinking.
Okay.
They offer a level of precision and control that traditional text prompts just can't match.
So it's not about replacing English with code, but recognizing that code brings its own unique strengths to the table.
Wow.
It's another way to communicate with these LLMs,
Exactly.
tapping into a different side of their capabilities.
Precisely. Code has evolved over decades to be incredibly efficient and unambiguous. It's a language designed to instruct machines, and now we're exploring its potential for instructing these very powerful language models.
It's like we're bridging the gap between human language and machine language,
Yes.
using code as this common ground for understanding.
Yeah.
But does that mean we all need to become expert programmers to effectively use LLMs in the future?
That's a valid concern, but I don't believe everyone needs to become a coding wizard.
Okay.
Just like with spoken language, there are levels of fluency with code.
Okay.
We might see tools
Okay.
that help us translate our intentions into code prompts, even if we don't know how to write the code ourselves.
Like a Google Translate for prompts, that would be amazing.
And we're already seeing early examples of such tools. Platforms are emerging that allow you to create prompts using visual interfaces or simplified coding languages.
How cool.
I expect these tools to become even more sophisticated and user-friendly over time.
That's reassuring. It would be a shame if the power of code prompts was limited to, like, only those fluent in coding.
Right.
Speaking of fluency, I'm curious about pseudocode. We discussed that second study where they used those pseudocode prompts with great success.
Right. Pseudocode is that fascinating middle ground between natural language and that formal code. It uses keywords and a very basic syntax to convey instructions,
Okay.
but without the strict rules and complexity of a full programming language.
So it's a more accessible way to utilize structure in our prompts.
Yes.
But is there a trade-off? Does using pseudocode limit the potential of code prompts in any way?
That's a great question. researchers are still investigating whether using pseudocode sacrifices any of the precision or control that you get with formal coding languages. However, it also has the potential to make code prompts more accessible to a much wider audience.
It seems like it's a balancing act.
It is.
We want to harness the power of structure without sacrificing accessibility or ease of use.
Exactly. That's where further research and experimentation come in. We need to explore different approaches to code prompting, different coding languages, complexity levels, and even hybrid approaches that combine elements of code with natural language.
We're on this quest for the perfect prompt recipe.
We are.
And like any good recipe, we need to experiment with different ingredients and techniques to find what works best.
Absolutely.
Speaking of experimentation, I'm curious.
Yeah.
What are your thoughts on the potential for teaching LLMs to generate their own code prompts?
Whoa.
Could we reach a point where they can, figure out the most effective prompts for a given task?
That's a fascinating idea.
Yeah.
It might seem like a far-fetched concept.
Yeah.
But consider the strides that LLMs have made in code generation and understanding complex instructions.
Right.
It's not a huge leap to imagine them mastering the art of prompt engineering as well.
So the future of prompting might involve LLMs prompting other LLMs.
Exactly.
That's a mind-boggling concept.
It is.
But let's ground ourselves for a moment and bring it back to our listeners.
Okay.
What advice would you give to someone eager to start experimenting with code prompts today?
I would say my advice is to start simple and don't be afraid to experiment.
Okay.
Try different coding languages, styles, and complexity levels.
Okay.
There's no one-size-fits-all approach. The key is to just get hands-on and discover what works best for your specific needs and goals.
It's all about exploration and discovery and seeing how these code prompts can enhance the ways that you already use LLMs.
Precisely.
Yeah.
It's about expanding your toolkit, and code prompts are a very valuable addition. They offer a new way to communicate with these powerful models, and who knows what exciting possibilities lie ahead as we delve deeper into this fascinating field.
Well said. We've covered a lot of ground today.
Yeah.
From the nitty-gritty details of code prompt styles to the broader implications of this emerging technique. Before we wrap things up, I'd like to leave our listeners with one final thought-provoking question.
Oh, go ahead. Intrigue our audience.
Could the future of prompting blur the lines between code and natural language entirely? What if we reach a point where the distinction between the two becomes irrelevant and we can interact with LLMs using a seamless blend of code and language, switching between them effortlessly as needed?
But that is a thought-provoking question.
Yeah.
It challenges us to rethink the very nature of communication and the boundaries between human and machine language.
Yeah.
It's a question that will likely fuel research and innovation for years to come. And who knows?
Yeah.
Perhaps the answer lies in the creative minds of our listeners who are now equipped with a deeper understanding of this fascinating world of code prompts.
I love that. Welcome back. I'm ready to wrap up this deep dive into code prompts.
Sounds good.
We've covered a lot of ground.
We have.
From the research to real-world applications, and even touched on the future of prompting. But before we get too carried away with the possibilities, let's take a moment to synthesize what we learned from those research studies.
Absolutely. The key takeaway here
Yeah.
is that code prompts are not just a passing trend.
Okay.
They represent a potential paradigm shift in how we interact with LLMs. They provide a level of precision and control that traditional text prompts sometimes lack.
So it's not about abandoning natural language altogether.
Right.
But recognizing that code offers a different and often more effective way of communicating certain types of instructions to these models.
Precisely. Code has this inherent structure and logic that machines, including LLMs, seem to readily grasp.
Yeah.
We've seen this in the research,
Right.
where code prompts consistently performed well on tasks that require reasoning and logical thinking.
And remember, it's not just about the structure of the code itself.
Right.
Those ablation studies show that the content within the structure is crucial too.
It is.
Adding comments and meaningful variable names significantly boosted performance,
Right.
suggesting that we're not just instructing LLMs, but also providing context and clarifying our intentions.
Yes, those findings were quite revealing.
Yeah.
They highlight the importance of thinking about code prompts as a form of communication, not just a set of instructions. We're essentially teaching these models to think more like programmers, breaking down tasks into their logical components
Okay.
and providing clear, well-documented guidance.
It's like we're giving them a new language to think in, a language that resonates more deeply with their machine learning roots.
Yes.
But if code is the key to unlocking these new levels of LLM performance,
Right.
does that mean we all need to become coding experts
It's a good question.
to effectively leverage these models?
Not necessarily.
Okay.
Well, while a deeper understanding of code can certainly be beneficial, I don't believe everyone needs to become a master programmer.
Okay.
Remember those tools we discussed?
Yeah.
The ones that help translate our intentions into code prompts.
Right. Yeah, like a Google Translate for prompts.
Exactly. Those are going to become increasingly important as code prompts gain wider adoption.
Right. Those visual prompt builders and simplified coding languages could really help democratize access to this powerful technique.
Yes, they could.
Yeah, it would be a shame if code prompts remained exclusive to only those fluent in coding.
Agreed. And as these tools evolve, they'll likely become even more intuitive and user-friendly, allowing anyone, regardless of their coding background, to harness the power of code prompts.
That's encouraging. It means we can all benefit from these advancements, even if we don't know how to write complex code ourselves.
Exactly.
But speaking of code, I'm curious about your thoughts on pseudocode.
Yeah.
Do you think it has a future in this world of code prompting?
Pseudocode is definitely an interesting area to watch.
Okay.
It strikes a balance between the clarity of code and the accessibility of natural language.
Okay.
Remember those pseudocode prompts?
Yeah.
Performed remarkably well in that second study.
Yeah.
Demonstrating that you don't necessarily need a formal programming language to reap the benefits of structure.
So it's another tool in the toolbox.
It is.
Another way to bridge that gap between human intentions and machine understanding.
Precisely. And as this field progresses,
Yeah.
we might even see more innovative approaches to prompting, perhaps even hybrid methods that seamlessly blend code with natural language,
Oh, wow.
allowing us to communicate with LLMs in ways we can't even imagine yet.
It's exciting to think about where this is all heading.
It is.
And for our listeners who are eager to jump in and start experimenting with code prompts today, what advice would you give them?
My advice is simple. Don't be afraid to experiment.
Okay.
Start with a simple task. Choose a coding language that feels comfortable and play around with different prompt styles and complexity levels. See what works best for you and your specific needs.
That's great advice. And remember, it's not about replacing everything you do with code prompts. It's about expanding your repertoire, adding another tool to your LLM toolkit, and exploring new possibilities.
Absolutely. It's about embracing this evolving landscape of human-machine communication and seeing where this journey of discovery takes us.
And on that note, I think it's time to wrap up this deep dive.
That's good.
We've explored the research, witnessed real-world examples, and even pondered the future of code prompts.
We have.
But most importantly, I hope we've sparked a sense of curiosity and inspired our listeners to dive in and start experimenting themselves.
I couldn't agree more. Keep exploring, keep questioning, and keep pushing the boundaries of what's possible with these incredible language models.
Until next time, happy prompting.